I am Dr. K Sridhar. I'm a neurosurgeon. I'm the director of the Institute of Neurosciences and Spinal Disorders at the Global Health City, Chennai, India. As far as neurosciences is concerned, presently India is very high up on the global stage. Previously, historically speaking, when you go back thousands of years to the time of Shushruta, we were perhaps leaders in neural science and neurosurgery and ophthalmic surgery and things like that. But then with the advent of Western style of medicine, there came a time when the Indian style of medicine and the knowledge of that time came down, and then we had a lot to catch up with. But I think truthfully and very proudly we can say that presently in the 2017 and 2016 that we are there with the top countries as far as neurosurgery and neurology is concerned. Any procedure or any treatment which is available anywhere in the world is possible and is being done here in this country, in many centers across the country as well. Previously, very often people used to say we have to travel abroad to get the best treatment, but it's no longer necessary, and very often people do come from all over the world now to India and to the metropolitan cities of this country to get high-end neurosurgery done, because it's being done here with the same professionalism, the same standards of care as anywhere else in the world. So I think as far as neurosurgery and neurology is concerned, we can say that India is up there, compared to all other countries in the world. Neurosciences has over the years changed drastically in different ways. The first is the diagnosis of various diseases. The most important contribution has been from the coming out of modern MRI and CT machines with their new softwares. With the softwares that they have, we can now study in depth not only the structure of the brain, but we can also study the functionality of the brain. We can see how the blood flow to the brain is, and we can compare all of this relative to each other, which makes it an amazing thing to actually know what is happening to the brain and why. Now, once we know what is happening, then the same technology advancement which has happened over the last 20 to 30 years has brought in many new drugs to help us treat many of the problems that we thought were not treatable. And that is again a big advance. Things like multiple sclerosis and other diseases have now many drugs where patients can be helped. The other advancement has been in monitoring of patients in the critical care and in the operation theatre. We can now, as we operate, and that too operating with high-end microscopes and precision instruments that are available now, we can now do precise surgery to the millimeter, and we can do safe surgery with intraoperative monitoring. We have monitoring of almost all aspects of brain function, and we can titrate the amount of anesthesia given what is needed for the patient. And as we are doing that, we can monitor. Not only this, post-operatively also the monitoring has improved and tremendously, and I'm not, as a neurosurgeon, scared anymore of doing a major operation on the brain, whether it's a brain stem surgery or whether it's an arteriovenous malformation. These are all very major, serious operations. But I'm not scared anymore because we now have the technological support to do all this. And that's the most important thing for an advancement of treatment of a particular patient. And the other concept which has come in now is early rehabilitation, and which has now also progressed, so that not only are we now able to diagnose a patient early, we can treat a patient with extremely good medicines. We have high-end technological surgical equipment and monitoring available, and at the same time we start rehabilitating the patient so that their quality of life post-treatment and during treatment remains very good, and the patients can lead a productive life and give back to society. I think that is where we are at now. And looking at the future, there is a lot of research, and there is a starting of work on neuromodulation going on. Neuromodulation surgery is where you can actually change brain function by doing something to brain cells or the brain supportive structures. One example of neuromodulation surgery is, of course, deep brain stimulation, where you actually stimulate a particular neurons, a group of cells, the subthalamic nucleus, so that the patient's symptoms of Parkinson's goes away. Now, deep brain stimulation is also being used for other movement disorders, for some psychiatric problems like OCD, and therefore this is a type of neuromodulation which can happen. You also have neuromodulation where you have brainstem implants for deaf-mute children and other things like this. Where we are now, research is being looked at is also looking at stem cells in brain and spinal cord recovery. Unfortunately, headway has not yet been made in that we have not been able to actually have a reproducible model. But I'm sure in a decade we will have some answers on this. Similarly, in things like neuro-oncology, where in cancers of the brain, we are now looking at targeted therapy for these brain tumors. So a lot of groundbreaking work is being done. And if you look at, for example, I look at the work being done now and which I can do now, and what was being done when I was a resident 25, 30 years ago, there is a huge difference which we are now making to the quality of life of people, and in the aspect of how we can treat people and how much relief we are giving patients. I've told you now how good things are, but it's not without challenges. Challenges are there. I think the basic challenge in neuroscience and neurosurgery is that we still have not completely understood brain function. And that is one of our biggest challenges. We are still learning every day how the brain functions and how each part of the brain survives and how to make it function better. We are learning that the brain functions by having electrical energy change into chemical energy, which then changes again into electrical energy, and then that is manifest as movement or thought or whatever. But more than that, we have more knowledge about structure, we have more knowledge about perfusion of the brain and the chemicals involved in the brain, but we have still not got 100%, or forget 100%, we don't even have about 40% knowledge. And that is where our biggest challenge is as far as understanding the brain so that we can do more to treat brain. On the ground, the challenges in India is the vastness of the country and the population. How do we deliver healthcare and standard of healthcare, standard of care to a population which is varied in both culture, economics, and language, and all sorts of ways. And that is the biggest challenge. The challenge is that we need to explain to the patient, irrespective of where they come from, what economic background they are, what the patient's problem is. And they need to understand the significance of what we are saying and how important it is for them to come back and continued treatment which is being given to them. And sometimes that is a major challenge. One of the major things that we listen to when we talk about research in neuroscience in this country is the follow-up of patients who come for treatment. And this is a fact whether it's in a major institution, government institution, or a major private institution. Follow-up of patients, because it is important for society to be aware and understand what is happening in neuroscience. And these are the main challenges. Of course, some of the challenges involve policies on the ground, for example, wearing a helmet, wearing seat belts, which are still not completely implemented in many parts of the country. While there have been technical advances, there are challenges, but concepts in treatment in neuroscience, whether it's neurosurgery, neurology, are changing. The era first was of saving life. In the 1950s and 1960s, it was a life-saving treatment, whatever it was. And then it came to treating the illness and the patient's symptoms. So the patient had a symptom, then you treated the patient. But presently the concept has changed from that into preventive intervention. That is, you intervene so that you prevent symptoms and signs from coming in the patient, so that the patient does not suffer a disastrous problem and then you don't go about doing things. So the concept, present day concept, is to prevent a problem. For example, let me give you a particular example. Children born with the spinal dysraphism, if they have a tethered cord, but they don't have as yet bladder symptoms or gross deficits. Previously, the thought used to be, let the child develop a problem and then you operate. But presently, we don't wait. We operate soon after the child is born, sometimes even a month or two after the child is born, or as soon as the child is fit to have surgery. So that is what I am talking about. So because we don't want the child to develop a problem and then operate, we want to prevent the problem from happening. It's the same with stroke, it's the same with different problems in the brain that we do now. So the concept presently is preventive intervention.